But before you can start programming the robot, you have to configure the gripper. In this module, you will learn how. For the robot to work optimally, it needs specific information on the attached end effector. It needs to know the position of the tool center point and the end effector's center of gravity. These values are defined as the distance from the center of the tool flange to the position of the point. Finally, the robot needs to know the payload, which is the weight of the end effector. We'll start by determining and configuring the tool center point. The tool center point, or TCP, can be found by finding the points of contact between the tool and the workpiece. The TCP is located in the center between the points of contact. Let's do a few exercises to train you in finding the TCP. Where's the TCP on this gripper? That's right. The TCP is in the center between the points of contact. Where is the TCP on this vacuum gripper? That's right. The TCP is in the center between the points of contact. Where's the TCP on this glue dispenser? That's right. The only point of contact is the end of the nozzle. This is also the TCP. Now, you know how to find the TCP. The next step is to configure it in the software. The robot needs to know the position of the TCP relative to the tool flange. This is done by entering up to 3 position coordinates, X, Y, and Z. Let's configure the TCP for this gripper. To configure the TCP, start by clicking the Installation button in the top ribbon. Then click the TCP button in the left menu. Here, you enter the position coordinates of the TCP you want to configure. When the TCP is located directly on the Z-axis, like here, and not offset on the X and Y axes, the easiest way is to just measure the distance from the tool flange to the TCP. Now, grab the ruler and measure the distance from the TCP to the tool flange. Afterwards, click the Teach pendant icon. Enter the distance in millimeters in the Z field. You have now configured the TCP. If the TCP is offset on all 3 axes, like this glue dispenser, it can be difficult to measure the exact position of the TCP. In this case, you can use the robot's TCP position wizard, and the robot can calculate the TCP position. To teach the robot the TCP, start by moving the TCP to a reference point and save this point. Then move the TCP to the same point, but from another direction, and save the point. Repeat from different directions until you have 4 points. The robot can now calculate the TCP position. Let's teach the robot the TCP of the glue dispenser. Start by clicking the TCP position wizard and click Set Point 1. Now, grab the TCP and move it to the reference point. The TCP is at the correct position. Click the Teach pendant icon. Click OK to save. Click Set Point 2. Move the TCP to the reference point. The TCP is at the correct position. Click the Teach pendant icon. Click OK to save this point. Click Set Point 3. Grab the TCP and move it to the reference point. The TCP is at the correct position. Click the Teach pendant icon. Click OK. Click Set Point 4. Move the TCP to the reference point. The TCP is at the correct position. Click OK then click the Set button. Using the 4 points, the software has now calculated the TCP position, which is inserted in the relevant fields. Sometimes, a tool may be attached at a different angle, meaning that it is not parallel with the z-axis of the tool flange. If this is the case, the robot needs to know the orientation of the tool, which the software can calculate. To do so, position the tool parallel with the z-axis of the base. To teach the robot the tool orientation, start by clicking the TCP Orientation Wizard. Next, click the drop-down menu in the right window and select Base. Then click the Set Point button. Position the z-axis of the tool parallel with the z-axis of the base. The z-axis of the tool is now parallel with the z-axis of the base. Click the Teach pendant icon. Click OK to use this position. Finally, click the Set button. The software calculates the orientation of the tool and inserts it in the relevant fields. Now you have learned 2 different ways to configure the TCP and how to teach tool orientation. The next step is to configure payload and center of gravity. Remember, payload was defined as the weight of the tool, and the center of gravity is the point on the tool where the weight is distributed evenly on each side. Start by clicking the Payload button in the menu to the left. The software can calculate both the payload and center of gravity. To do so, click the Wizard button. Calculating payload and center of gravity is done similarly to teaching the TCP, by moving the robot into 4 different positions. To move the robot to the first position, click the Next button and click Set Position. When teaching payload and center of gravity, it's important that you don't touch the tool or tool flange, as this may distort the calculations. Instead, grab the robot by the wrist and move it to the tool outline. The robot is at the correct position. Click OK to use the. You have configured the first position. Click the Next button and Set Position. Move the robot to the next position. The robot is at the correct position. Click OK. You have configured position 2. Click Set Position. Move the robot to the next position. The robot is at the correct position. Click OK. You have configured position 3. Click Set Position. Move the robot to the next position. The robot is at the correct. Click OK. You have configured all 4 positions. The software uses the 4 positions to calculate the payload and center of gravity. To use these values, click the Finish button. To set as the active payload and center of gravity, click the Set Now button. You can teach multiple payloads and centers of gravity, which you can name for ease of use in the programming. For example, one for the empty gripper and one for the gripper holding a workpiece. You have configured payload and center of gravity. Now that you know how to configure an end effector, let's return to the Pick and Place application. This is where we left off in the previous module. Now, your task is to configure the TCP, payload, and center of gravity for this gripper. You have now configured the TCP, payload, and center of gravity for this end effector. Well done! In the next module, you will learn how to program all the motions and waypoints needed for the pick and place application. Configure the gripper used for this pick and place application. You are now ready to start the programming. In this module, you will learn the characteristics of the robot's different motion types and when to use them. Then you will program all 6 waypoints needed for this application. In its simplest form, a robot program consists of a number of waypoints and motion between these waypoints. To insert a motion and a waypoint, click the Move button on the left side of the screen. A motion and a waypoint are inserted in the program tree. The waypoint contains the coordinates that the robot TCP will move to, and the motion determines how the robot moves the TCP from one waypoint to another. The default motion is Move J. Let's look at its characteristics and when to use this motion type. When using a Move J, also known as a joint motion, the robot moves the TCP from one waypoint to another in a nonlinear path. Since the TCP doesn't have to follow a specific path, the robot is able to move faster than in other motion types. Use this motion type when the path of the TCP is not important and when moving in free space. In the program tree, you can change the motion type. To do so, click the drop-down menu in the upper right corner and select Move L. Move L is a linear motion that moves the TCP on a straight path from one waypoint to another. This motion type is typically used when the robot has to pick or place an item and the path of the TCP is important. For example, to put an item straight down or when lifting it and clearing it from a surface. Move L is also suitable for precise motion in confined space to avoid collision. The last motion type is Move P. Click the drop-down menu in the upper right corner and select Move P. Move P, or Move Process, is somewhat similar to Move L, since the motion of the TCP is also linear. The distinct feature of Move P is that the TCP moves at a constant speed, which is particularly useful in robot programs for welding or dispensing glue to ensure even distribution. When maintaining a constant TCP speed, the TCP is not able to make sharp changes of direction at tight angles, as this would require the TCP to slow down. To maintain the TCP speed, the robot has to make a softer turn, which is called a blend radius. Without any sharp turns, the robot is then able to move the TCP at a constant speed. When Move P is used, it's also possible to make a circle move. Click Add Circle Move. A circle move consisting of 2 waypoints is inserted in the program tree. A circle move must always be preceded by a waypoint from which the robot will start the circle move. The first waypoint of the circle move specifies the via point on the circular arc, and the second waypoint is the end point of the circle move. Now that you know the motion types, your next task is to determine which motion type to use at each of the 6 waypoints needed for this pick-and-place application. Then program the motions and waypoints in the software. At the first waypoint, the robot has to move from the starting position to the left conveyor. Which motion type do you want to use here? The robot is moving in free space, and the path of the TCP is not important. Move J is the best choice here. To program the first waypoint in the software, start by clicking the Move button. A motion and a waypoint are inserted in the program tree. Click the waypoint in the program tree to configure it.
Then click the Set Waypoint button to the right of the program tree.
Now use the move arrows on the Teach pendant to move the robot to the red waypoint. Afterwards, click OK on the Teach pendant. Click OK. You have now configured waypoint 1. At waypoint 2, the robot has to move down to pick the workpiece. Which motion type do you want to use here? Yes, move L is the best choice to move straight down and pick the workpiece. To program waypoint 2, start by clicking Move J in the program tree. Then click the Move button. To change the Move J to a Move L, click the and select Move L. Next, click Waypoint 2 in the
and the Set Waypoint button.
Position the robot at the next waypoint and then save the waypoint. Click OK to. You have now configured waypoint 2. At waypoint 3, the robot has to move the workpiece up and clear of the conveyor. Which motion type do you want to use here? Yes, Move L is the best choice for moving the workpiece clear of the conveyor. To insert another waypoint with the same motion type, click the Waypoint button in the left pane.
And then click the Set Waypoint button.
Move the robot to waypoint 3, and afterwards, click OK on the Teach pendant. Click OK. Move the robot to waypoint 3, and afterwards, click OK. Click. You have now configured waypoint 3. You have set up the first 3 waypoints needed for this application. Now, your task is to set up the remaining 3 waypoints, but without any guidance. Here, the robot has to move to the red waypoint located above the box on the other conveyor. Consider which motion type to use, and then click Start Programming when you are ready to begin. You have now configured waypoint 4. At waypoint 5, the robot has to place the workpiece in the box. Consider which motion type to use, and then click Start Programming when you are ready to begin. You have now configured waypoint 5. At the last waypoint, the robot has to move clear of the workpiece and the box. Consider which motion type to use, and then click Start Programming. You have now configured waypoint 6. You have set all the waypoints needed for this application. In the next module, you will learn how to interact with the sensors, operate the gripper, and how to adjust the payload when picking and placing the workpiece.